Hey guys, welcome to my channel. This is Saritha. I have been training JEE aspirants from past 23 years in mathematics, and today I've come up with mixed concept questions, and these are real game changers in JEE Advanced. And if you are able to solve these questions, it keeps you ahead from others, and these are not straightforward to solve and move on. In fact, they test you how deeply you understand the connection between two or more topics. And that's where exactly I'm going to help you with to identify such questions and what are the approaches to solve them efficiently. If you are aiming to be in the top rank, stay tuned with me till the end of the video, as I'm not only going to discuss the strategies but also give some common examples that will train your brain to think like a JEE examiner. I hope you will like the video. Please share it with your friends and hit the like button. So let's dive in. So let's see this question. There's an equation given which has a root lying in the interval a raised to 1 over 20, 22, b raised to 1 over 3, where a and b belongs to natural numbers greater than or equal to 2. And we need to evaluate this integration. So basically we have to find the integration. So let us take that integral. And the moment we see there exists a root lying for an equation in a given interval, we generally think of Rolle's theorem. And as soon as you see in the integration, first thing which strikes is substitution. So let x square is equal to t. So with this substitution, the integration will convert to integral a to b cos t by b raised to 2 by 3 divided by cos t plus cos of 263 minus t dt. And with a 2 in the denominator, because x square, when you differentiate 2x dx will be dt. So we have regularly seen these kind of questions where a plus b minus x property will be applied. So when we apply that property, and it should satisfy the condition that a plus b should be the sum of the limits, especially, it should be equal to 263. So this is the first condition. We get it when we observe the integration and go ahead with the substitution and applying the property f of a plus b minus x. And now to evaluate a and b, to complete the integration, we'll go back to the other condition and other concept used here, that is the Rolle's theorem. So we generally take the differentiation of the function as a given equation in order to prove that there is a root for this equation in the given interval. 12138 x raised to 2022 minus 119x plus 174. So defining fx by integrating, it would give x raised to 2024 by 2024 minus 12138 x raised to 2023 by 2023 minus 119 x square over 2 plus 714x plus c. So on further simplifying this, we are going to get x raised to 2024 by 2 minus 6x raised to 2023 minus 119 by 2 x square plus 714x plus c. So as per the Rolle's theorem, we need to verify the condition that at endpoints the function value should be same. Like that is f of a raised to 1 over 2022 should be f equal to f of b raised to 1 over 3 for a root to lie in this interval. So when we think of that, like f of a raised to 1 over 2022, and plug in this, it will lead to A into A raised to 1 over 2024 divided by 2022 will be 2 by 2024 divided by 2 minus 6 times A raised to A into A raised to 1 over 2022 minus 119 A raised to 2 over 2022 by 2 plus 714 A raised to 1 over 2022 plus C. Now, if you carefully observe, there are similar terms which are available here. This is 22. And with this observation, I'll try to assume that A by 2 should be equal to 119 by 2, which in turn, I think I can guess A as 119. Now, substituting A as 119 in the equation, it leads to f of A raised to 1 over 2022 is C. And simultaneously, when I plug in A as 119 here, and B, I will get it as B raised to 2 by 3, I'll get it as 144. Okay? And all these conditions will satisfy if you verify them. So, even if you plug in B raised to 1 by 3 in above function, it will satisfy. So, there exists a root of f dash of x in this given interval. That is verified. So, now we got to know the values of A as well as B. So, in order to complete the integration, it would be 2 times 119. And the upper limit is actually B raised to 2 by 3, which is 144 cos t divided by cos t plus cos of 263 minus t dt. So generally, if I try to find the value of this part of the integration, I would get this as 25 over 2, because the difference of the limits is 25, and then we'll evaluate it for 2i. So this should give you the answer as 25. So basically, although there is some kind of lengthy working in this, but the connection of the concepts here are very, very clear when you actually look into the question itself. Firstly, we are using integration concept and integration properties. Secondly, we are using the Rolle's theorem to show, to apply that there is a root lying in that interval. And assuming the A value is not so easy, it needs a careful observation with the construction of the question. So normally, if you want to solve such a fraction equation, it is very difficult. But with the observation and the intuition, you can always check with the guessed value. So this problem is an advanced question where multiple concepts are used. Hence, this is how we need to connect the concepts. I hope you like this example and hope you have learned certain observation in identifying and connecting the concepts. So stay tuned with me for more such interesting methods, and please hit the like button. Bye for now.